Z.ai just dropped GLM 5.1, and it is the new #1 open-source model on SWE-Bench Pro. It beat GPT 5.4, Opus 4.6, and Gemini 3.1 Pro. But here is the thing. The benchmark score is not even the most impressive part. What makes GLM 5.1 different is that it actually gets better the longer you let it run. Most models plateau after a few dozen attempts. This one ran for 8 hours straight and kept finding improvements the whole time. Let me break down exactly what happened and why it matters. Here is the core problem with current AI coding models. They hit a wall fast. You give them a coding task, they apply their standard toolkit of tricks, get some quick wins, and then they just stop improving. Giving them more time does not help because they have already exhausted their repertoire. GLM-5 was like this too. Quick initial progress, then a flat line. GLM 5.1 changes this completely. It is specifically built for what Z.ai calls long horizon tasks. It can run autonomously for hours, revisiting its reasoning, revising its strategy through thousands of iterations. The longer it runs, the better the result. This is a fundamentally different approach to agentic coding. Let us look at the numbers. GLM 5.1 scores 58.4 on SWE-Bench Pro. That is #1 in open source and #3 globally, ahead of GPT 5.4 at 57.7 and Opus 4.6 at 57.3. On NL2 repo, which tests whether a model can generate an entire repository from a natural language description, GLM 5.1 scores 42.7. That is a massive jump from GLM 5 at 35.9. On Terminal Bench 2.0, which tests real-world terminal tasks, it scores 63.5, up from 56.2. These are not marginal improvements. GLM 5.1 also scores 68.7 on CyberGym for cybersecurity tasks, nearly catching Claude Opus 4.6 at 66.6. And it crushes on BrowseComp at 79.3 with context management. So across the board, this is a serious open-source contender. Now here is where it gets really interesting. Z.ai tested GLM 5.1 on a vector database optimization challenge called VectorDB-Bench. The task is to build a high-performance approximate nearest neighbor search in Rust. The previous best score was 3,547 QPS, achieved by Claude Opus 4.6 in a 50-turn session. But what if you remove the turn limit? GLM 5.1 ran for over 600 iterations with 6,000 tool calls. It went from 3,547 QPS all the way to 21,500 QPS. That is a 6 times improvement. The optimization trajectory shows a staircase pattern. Periods of incremental tuning, then sudden structural breakthroughs. Around iteration 90, it switched from full corpus scanning to IVF cluster probing with F16 vector compression, jumping to 6,400 QPS. Around iteration 240, it introduced a 2-stage pipeline with U8 pre-scoring and F16 re-ranking, reaching 13,400 QPS. 6 such structural transitions happened over the full run, each one initiated by the model itself after analyzing its own benchmark logs. The second test was Kernel Bench Level 3. This benchmark asks the model to take a reference PyTorch implementation and produce a faster GPU kernel with identical outputs. We are talking about optimizing full model architectures like MobileNet, BGG, MiniGPT, and Mamba. 50 problems total. For reference, Torch.compile with max autotune gets about 1.49 times speedup. GLM 5.1 delivered 3.6 times speedup and kept improving well into the run. GLM 5 tapped out early. Claude Opus 4.5 lasted a bit longer but also plateaued. Opus 4.6 leads at 4.2 times, but GLM 5.1 is closing that gap from the open source side. The key difference is that GLM 5.1 sustains useful optimization for substantially longer than its predecessor. It does not just try the same thing harder. It actually finds new strategies as it goes. The third scenario has no numeric metric at all. Z.ai asked GLM 5.1 to build a Linux-style desktop environment as a web application. No starter code, no design mockups, no intermediate guidance. Just a single prompt and let it run. Most models produce a basic skeleton with a static taskbar and maybe one placeholder window, then declare the task done. They have no mechanism to step back and ask what is missing. GLM 5.1 ran for 8 hours in a self-review loop. After each round, it evaluated its own output, identified what could be improved, and continued. The progression is remarkable. Early on, you get a basic layout with a simple taskbar. Then a file browser appears. Then a working terminal. A text editor. A system monitor. A calculator. Games. Each new feature integrated into a coherent UI, not bolted on as an afterthought. By the end, you have a complete, visually polished desktop environment running entirely in the browser. This is what becomes possible when a model can actually sustain productive work over long sessions. GLM 5.1 works with your existing coding agents out of the box. Claude Code, Open Code, Kilo Code, Roo Code, Klein, Droid, and more. You just set the model name and go. It is fully open source under the MIT license with weights available on Hugging Face. You can run it locally with VLLM or SGLang, or use the Z.ai API. There is also Z-Code, their GUI that lets you develop on remote machines over SSH or kick off tasks from your phone. The whole setup is fully local and works with whatever coding agent you already use. GLM 5.1 is a serious entry in the coding agent race. Number 1 open source on SWE-Bench Pro. 6 times improvement on vector database optimization. 3.6 times speedup on GPU kernels. A full Linux desktop built from scratch in 8 hours. All open source, all MIT licensed. Weights on Hugging Face, API at Z.ai. Check the links in the description. If you found this breakdown useful, subscribe for more deep dives on the latest AI model releases.